This is A Radhika. I am going to discuss about power electronics video lecture on applications of power devices and classification of UPSs. Today's class only explanation for UPS. So in last classes we discussed basics of introduction of UPS. Now we are going to discuss about the online and offline UPS means classification of UPS. So on the completion of this class, we would be able to understand the concept of UPS and classification of UPS. So here this is the figure per UPS. The UPS. Actually, what is the UPS? UPS means uninterrupted power supply. So, the classification of UPS are offline UPS and online UPS. The UPS are two types, offline UPS and online UPS. And also, the classification of UPS will be two are further classified as offline preferred type, offline interactive type and online preferred type. So these are the under classification of offline and online UPS. So here first we are going to discuss about the offline UPS. Before going to this one, just we will discuss about the few terms of UPS. So here, so in this, actually, what is the need of UPS? Critical loads like computers, communication equipments, biomedical instrumentation systems, surgical and post-surgical medical equipment, etc., requires a continuous as well as quality power supply. These loads can't tolerate power outages, power fluctuations, over or under voltage, and variations in the supply frequencies. Hence, an additional device is needed to supply the power to the critical loads without power failures, even for a moment. Such a device is called UPS. It's called UPS. And the UPS are classified into offline UPS and online UPS. These two are further classified as offline preferred type, offline interactive type, and online preferred type. So, the offline UPS, the main AC supply is impressed directly to the critical loads and simultaneously to charge the battery, which is kept as backup supply during the main power failure. The changeover take place within 1 by 4 cycles. In online UPS, irrespective of the input or mains, the power is continuously supplied to the critical load through the inverter of the UPS. Now we are going to discuss about the offline UPS. So here in offline UPS, the main AC supply is impressed to the critical loads and simultaneously to charge the battery which kept as backup supply. During the main power failure, the changeover takes place within 1 by 4 cycle. This type of UPS are cheaper and control is simple. In online UPS, irrespective of the input or mains, the main power is continuously supplied to critical load through the inverter of the UPS. So, this is the diagram for offline preferred UPS. Offline preferred UPS. So in this diagram, we have the input main supply. Here, this is the input main supply to static switch, normally off, that is the S1, and also the output to load. Finally, this is the directed from mains, and also it converts AC to main transformer to battery to DC and grounding to inverter, means AC to DC to AC converter, and AC quasi square wave to static switch to load. So this is the yeah. So here the functional block diagram of offline preferred UPS, it consists of independent battery charge circuit, load circuit which is supplied through static transfer switched S1 during main power on and through battery, inverter static switch S2 during power failure. Here during normal mode, main supply is available. The battery, means nickel cadmium, is charged through AC to DC converter and a charge controller, and the load supplied through static switch S1. During power failure, static switch S2 operates and battery supplies power to the load through inverter. Normally, single pulse quasi square wave AC voltage is generated by an inverter of offline UPS. The changeover of the supply from S1 to S2 is completed within 1 by 4 cycles so that the operation of the load is not disturbed. The backup during depends on the capacity or rating of the battery and its charge capacity prior to the power failures. When the main power is restored, it is very necessary that reswitching action must be preferred from S2 to S1. Because of thyristor static switches, it will not occur instantaneously, but it will take place half cycle for turn off the conducting thyristor. This disadvantage can overcome by using MOSFET or IGBT based switches. So here, during the normal mode of battery is charged through AC to DC converter and the charge controller, and the load supplies through static switch S1. During power failure, the static switch S2 operates and the battery supplies power to the load through inverter. Normally, single phase quasi square wave AC voltage is generated by the inverter of offline UPS. The change over the supply from S1 to S2 is completed within quarter cycle so that the operation of the load is not disturbed. Also, the backup during depends on the capacity or rating of the battery and its capacity prior to the power failures. The, the disadvantage of thyristor static switches S1 and S2 can overcome by using MOSFET or IGBT based switches. So this is the offline interactive type UPS. In this also we have the input supply. VAR means ampere volt reactive. VAR means automatic voltage regulator. Static switch ES1 normally on. and line conditioner to critical load. And also it has charge controller, AC to DC converter, main transformer, inverter circuit. Charging current will be flow through available, and it will be connected to ground and power failure in case of power failures. So here, when the main supply is available, it charges the battery through the charge controller. In the event of power failures, S1 turns off. Now CPU starts working as an inverter feeding the load. So instead of using an independent charging unit, an inverter cum charger is used. So cost and size of the UPS reduced. Now, before going to online UPS, we will watch the one YouTube video for offline UPS.
Welcome to Power Electronics lecture series. Here in this session I'll be going to explain offline UPS. So in last session I have explained online UPS. Now in this session I'll be explaining offline UPS. So circuit of offline UPS is almost similar to online UPS, but if you see this circuit, there is one difference with respect to online UPS, and that difference is this switch is normally on and this switch is normally off, while in case of online UPS this switch is normally off and this static switch that is normally on. So that is what the basic difference which one can see in its functioning. Now in today's session I'll be explaining its working, and then after I'll explain specifications of offline UPS. So this offline UPS functions basically in two modes. First mode is when mains is available, and second mode is when mains is not available. So let us begin this with what if this mains is on. So when this mains is on, at that time this normally on switch that is normally on, and this normally off switch is normally off. So what will happen is this signal that will go through normally on switch and it will be delivering signal to the load. It will be delivering signal to the load, and at the same time this input that will be going to charge battery. So here this input signal that will be going to charge the battery, and that is what delivered to the load via normally on switch is normally on and normally off switch is normally off. So because of this switch is off, this signal will not reach over here. The reason is the switch is off, but at the same time it will be charging this battery, and at that time it will be providing signal to critical load. So first mode of operation, that is mains is on. So when mains is on, two switches are there. Normally on switch that is on and normally off switch that is off. So mains is delivering signal to the load and battery is getting charged. mains is on, at that time normally on is on, normally off is off. Mains is delivering signal to the load and battery is charging. And second mode of operation is when mains is off. So when mains is off, at that time there will be a transition of normally on switch to normally off, and normally off will be translated into on, and now backup battery that will be giving signal. So here this rectifier is having AC input, it gives DC output, and this battery that is having DC output. So here that is what translated into AC by inverter, and now that is what passing through this switch. The reason is now this switch is on and signal is delivered to the load. So inverter here translates DC signal into AC signal. Inverter translates DC signal into AC signal. So here in second mode, when mains is off, first of all there will be a switching of normally on is getting translated into off, and normally off is translated into on, and battery is delivering signal to the load. At the time battery is delivering signal to the load. So that is how it delivers signal to the load. So this is how second mode is working when mains is off. So that is what the case when power failure is happening. But here one thing that we need to see, and that is what will happen is when this mains is not available, there is a need of switching of this switch. So that switching takes 5 millisecond amount of time. So this switching of on to off and that off to on, that takes 5 millisecond time. So that we need to understand. So it will be taking 5 millisecond time, and then this battery will be delivering signal to the load. So that case is not there with online UPS. In offline UPS, there will be a switching in case of power failure. In case of online UPS, there will be no switching, and in case of offline UPS, there will be a switching during power failure. Now let us try to understand specifications of offline UPS. So here, first, what is output voltage? So output voltage, that is available in two cases. When mains is on, at that time output voltage is 230 plus or minus 5%, and when UPS is on, at that time output voltage is 230 plus or minus 0.5%. And what will be the output frequency? So output frequency, that is when mains is on, at that time it will be 50 Hertz plus or minus 3%, and in case of UPS is on, at that time it is there with 50 Hertz plus or minus 2 Hertz. So in case of mains on, it will be 50 Hertz plus or minus 3%. In case of UPS on, it will be 50 Hertz plus or minus 2 Hertz. Power rating, before that input voltage. So input voltage of battery, that is there with the rating of 24, 48 and 72 volt ampere hour. So that is how input voltage battery is getting charged, and that is what the rating which is available. Power rating is available with 1 kilowatt ampere, 2 kilowatt ampere. Time required to charge the battery is 3 to 4 hour. It provides backup of 30 minutes approximately. Transfer time to have static switch change, like say normally on to off and normally off to on, so that is there with 5 milliseconds. These UPS are available with the efficiency of greater than 85%. So that is what available with efficiency of about greater than 85%. Protection circuit that is required with mains over voltage protection. So mains over voltage protection is required. Output current protection, output current protection, and low battery protection. So low battery protection. Why? The reason is it only provides 30-minute backup. So it requires to have low battery protection circuit with this offline UPS. Thank you so much for watching this.
So now we watched the YouTube video about offline UPS. Now we are going to discuss about the online UPS. So this is the circuit diagram for online UPS. Here we have the static switch S2 normally off, and AC to DC converter, inverter, static switch S1, and it will always on, and also it will be connected battery. In case of main fails, the battery will be connected, and also finally it will be sent to CPU, PCU, and to critical loads. So in this, the block diagram of online preferred UPS, during main supply is available, the main power supply is fed to the load through converter, inverter, static switch S1, and PCU. As well as the same supply is utilized for charging the battery through converter. When the main power supply fails, the battery instantly supplies the power to the load through inverter, static switch S1, and PCU. Hence, power supply to the load continues without any interruption. In this method, in the event of failure of inverter, the main can be diverted to the load through the static switch S2, and its direction is presented by dotted lines. Instead of during SCR bridge, a MOSFET or IGBT based DC to DC converter is also used to charge the battery and to supply DC power to the inverter circuit, so that it will reduce the size and weight of the UPS as well as power factor of the circuit. So here in offline UPS, so now we will watch one YouTube video about online UPS.
So ultimately, uninterrupted power supply is being utilized in case of power failure is been happening. So here UPS, that is a device that is being utilized to provide continuous power to critical load even though there is a power failure. Now here basically online UPS, this category I will be explaining in this session. So let us try to understand what is online UPS. So in online UPS, circuit connection that is almost similar to offline UPS, where here we have one phase or three phase power supply that is been given to rectifier circuit, and that rectifier circuit is giving DC output. So ultimately here at input of rectifier, AC input is there and output of rectifier, that is DC. Now this DC signal that is been utilized to charge the battery. So here DC signal of output at rectifier will be utilized to charge the battery, as well as that could be given to inverter. So input of inverter is DC and inverter converts DC into AC. So output of inverter is AC. Then after there is AC static switch. So this is what AC static switch that is there after inverter, and that is what connected to critical load, and one AC static switch that is connected from three-phase mains. So ultimately AC signal that is been given to critical load. But when we talk about online UPS, the basic condition of online UPS is this static switch that is normally on and this static switch that is normally off. So let us try to understand how this circuit functions in three different modes. So first mode, that is when mains is on. So mode 1 working, where condition is when mains is on. So this is what mains means, input that is available. So at that time what happens inside? So when mains is on, at that time this three-phase or one-phase signal that is passing through rectifier, and that is what translated by AC to DC, and that signal is given to battery to charge the battery. So here charging is happening. So here charging is happening, and this main signal that is what translated to DC from AC by rectifier, and that DC again will be given to inverter, and that will be resulted into AC. And in this mode, normally on switch is normally on. So here this signal will be delivered to the load due to this switch is on. So that is how this mode functions. So mode 1, that is what when mains is on. So at that time mains signal converted to DC by rectifier plus charger. So this is what the first thing that is happening. Then that DC signal charges the battery and given to inverter. So this main signal that is charging the battery as well as it is given to inverter, and output of inverter given to load. Why output of inverter is given to load? The reason is switch normally on switch is on. Normally on switch is on, that's why this signal will be delivered to the load. So this is how first mode is working. Again, in first mode where mains is on, one phase or three phase AC signal that will be translated into DC by rectifier, that same signal will be charging battery, and that signal will be given to inverter to convert that DC into AC again. And normally on switch is on, so that signal will be delivered to the critical load. Now second mode of operation. So second mode is when mains is off. When mains is off means power supply is not available. So when power supply is not available, at that time battery will provide backup to the critical load. So in this case, this battery that is giving supply to the load via inverter. So this is what DC signal that is there with battery, that is getting translated into AC by inverter, and this normally on switch is on. So ultimately now that will be delivered to the critical load. So when mains is off, battery provides backup. Then inverter converts DC into AC, and output of inverter is given to critical load. How? It is normally on switch is on. So normally on switch that is on. That's why this output of inverter will be delivered to the critical load. Now in third mode of operation, what if this UPS is getting failed? So in third operation, what will happen? So in third operation, case is what if UPS is getting failed? So in case of this circuit, if this circuit which I have placed in box, if it is getting failed, so what will happen? So for that there is one condition here, and in that condition here three-phase supply, that is what passing over here, and this normally off switch that is getting on, and this normally on switch that is getting off. So now this signal will pass through this switch and it will be delivered to the critical load, and during that time we can have a maintenance of this circuit. So during that time we can have a maintenance of this circuit. So what if UPS is getting failed? So when UPS is fail, at that time switches are getting triggered. So normally off is getting normally on, and normally on is getting normally off. So this signal now that will pass through this path and it will be delivered to the load. So normally on switch that is getting off, and normally off switch that is getting on. So mains is giving signal to critical load. In this situation, mains is giving signal to critical load. So this is how UPS is having three different modes. First mode is when mains is on, second mode is when mains is off, and third mode is when UPS is failed. Now I'll explain few specifications which we need to understand before we buy any UPS. So I'll explain what are the ratings which is there, what are the specifications which is there with UPS. So power rating of UPS that is available by 1 kilowatt ampere, 2 kilowatt ampere, and 5 kilowatt ampere. So this is the power rating 1 kilowatt, 2 kilowatt, 5 kilowatt ampere that is available with UPS. Output voltage in India available with 230 voltage plus or minus 0.5 percentage. Output frequency that is available by 50 hertz plus or minus 2 hertz. Input voltage range that varies from 190 volt to 260 volt. So if input varies in this vicinity, there is no problem. It will be providing steady voltage as we have seen at output voltage and output frequency. Power factor that is greater than 0.8 and it is been utilized as lagging, and that too because of inductive load. So lagging power factor that is been utilized due to inductive load and it should be greater than 0.8. Backup time available with this online UPS from 30 minutes to 4 hours. So these sets of UPS available. Harmonic distortion, so that will be available with less than 5%. Efficiency of this set of UPS that is greater than 85%. And there are two different protection circuit which is required. One is over voltage and under cutoff protection. Over voltage under cutoff, and third is over current protection circuit is required for online UPS. So these three different circuits which is required to have a protection of online UPS: over voltage, under cutoff, and over current protection. So these are the basic specifications.
Now we watched the YouTube video lesson about online UPS. So now the main AC supply is Impress 2. The main line AC supply is Impress 2 critical loads directly and charged a battery. During power failures, changeover takes place within quarter cycle. In online UPS, the power is continuously supplied to the critical load through the inverter of the UPS. So now today we discussed about the concept of UPS, classification of UPS, and a few advantages and disadvantages, and we have the few quiz questions here and also few frequently asked questions. So this is the today class about online and offline UPS. In next class we are going to discuss about the ASMPS. Thank you.